Welcome, everyone. Thanks for joining us today. We're excited to welcome AP Systems to today's webinar. Just a few quick notes before we get started. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, feel free to use the Q&A button at the bottom of your screen. This will be monitored. It's my pleasure to introduce today's presenter, Zechariah Dorelli. Zach is an electrical engineer specializing in power electronics with more than 10 years of experience in the solar industry. His expertise spans the design, testing, troubleshooting, and certification of power electronics converters. In 2023, he transitioned into an application engineer role supporting solar inverter manufacturers, and he currently serves as application engineer at AP Systems. Welcome, Zach. Feel free to take it away.
All right. Thank you, Amber. Thank you for the opportunity. All right. Before I get started, can you confirm that you see my screen still there? Is it
Good to go.
okay, perfect. Okay, let's get started. Welcome everyone to today's webinar. I'm really excited today to be with Charge Solar to go over our product lines and again, thank you all for joining and thank you Charge Solar for the opportunity. All right, let's get started. Okay, just to give you a quick background about the company, who we are and what we do. So we are at AP Systems, we are a global MLPE manufacturer, modular level power electronics. We make microinverters along with some of accessories like combiner boxes. And one of our main line of products is also rapid shutdown devices. So you might be familiar with one of them or both. Like I know some of the installers they think we just make rapid shutdown devices, but not really. We make microinverters and rapid shutdown equipment actually came like later down the road. So just to go over the history, established in 2010, came to the US in 2011 with our first generation single module microinverter. And then in 2013, we came with a true three-phase microinverter as well as a dual input micros. And as mentioned in 2019, we opened up our RSD division called AP Smart to serve the market for the rapid shutdown requirements. Fast forward to today, we make microinverters, rapid shutdown devices, some of the accessories, and in 2023, we already reached over 10 million units globally. So that's the history and about the global footprint. We have two manufacturing bases, one in China, one in Vietnam, and we have 9 branches and 5 local warehouses across the globe. So that's pretty much what we are and what we do. And today we will talk about the microinverter architecture. I mean, you might be familiar with microinverters or not. If you're not familiar, this is a good, chance to learn about it. And if you already know them, I'll try to get into some details with the Q22 and QS2 and our AC combiner box. Okay, the typical residential application, right? A microinverters are very suitable devices for residentials, like almost no brainer. You get a microinverter connects to two modules. In the past it was single module, but two module is easy enough per microinverter in terms of installation. So that also reduces your BOM and the number of micros you will need. So two seems to be a good fit. But today they will also introduce quad microinverters. Hopefully that will be exciting for you guys. But so yeah, two or four for residential. And the way it goes is you basically mount the microinverter right on the rail. It's really easy to attach. There's a bracket on top, as you can see. Just slides into a slot there with a screw, tighten it, good to go. There's not really any other attachment needed. And then you would wire modules, PV modules to the inputs of the microinverter, and you would have a trunk cable for the AC, right? So that's pretty much it in terms of installation. You got the racking, put the microinverter, put the modules in, close the module on top, and Before that, obviously, just connect the AC output of the micro to the trunk cable. And you can refer to as branch or string or trunk. That's your AC cable that goes to your breaker panel, basically. And then you will go to the next step, which is the communication. For the communication, you go with the device we call ECU, which is an energy communication unit. For the residential application, you normally go with ECU-R. R stands for residential. It wirelessly communicates with all the microinverters and uploads that data to the cloud. You can also locally access all the inverters through the ECR. Now, keep in mind you don't have a direct communication between the micros and your device, your app or the portal. You need to go through the ECUR. So it is necessary for you to have this ECUR for the commissioning and for monitoring purposes. Now, ECUR for residential applications, it usually goes in your house. It stays maybe right next to your internet router. It's this device right there, ECUR gateway. It just looks like a regular internet router. It has Ethernet and Wi-Fi connectivity, so you can hardwire it to your internet router, or you can just have it on the Wi-Fi. Once it is online, it will pull the data. It already pulls the data, but once it's online, it's going to be uploading them to the cloud. So ECR just plugs into a wall outlet. So that's why you usually want to keep it in the house where you can have a outlet to plug that in for powering. But for the next one, for the commercial, we have a different ECU which can be used to direct the power from the line. So let's talk about the commercial applications. For the commercial applications, design is more or less the same. There's not really any different, except the fact that we supply Q22 inverters. Q stands for quad, T is three-phase, 2 is the second gen. So the difference is you're getting your microinverter and connecting it to four modules at a time. We don't have dual module for the commercial applications. We have quad for the simple fact that you want to reduce the BOM, right? You want to have less equipment. So four is an ideal number, really. I mean, anything beyond that is just going to make life a little bit more complicated, I think. So with four modules, it's not that difficult to wire four modules into the micros, especially for the commercial applications. And again, for the communication, still the same. It's Zigbee. It's a wireless communication over Zigbee. You get your ECU communicating with all the inverters wirelessly. For the commercial applications, again, by default, you can go with ECU-C. You can also use ECUR. Now, the differences are with the ECU-C, again, C stands for commercial, it has direct CT connections to it, and it can also connect the line voltages directly. You can also connect the line voltages directly to the ECU-C, which allows you to do power measurement. So that's the benefit of the ECU-C. If you want to have your production measured using the CTs, and you can also put grid CTs. That way you can measure import export as well as the consumption on your building. So if you're interested in doing power measurement on the PV production and grid import export and the building consumption, you go with the ECUC and attach these CTs, plug them in. Now you get the communication with the microinverters as well as the power measurement from the PV and the grid. But if you choose not to go with the ECEC for different purposes, let's say you're saying like, oh, ECUR is enough for me. Just going to go with ECUR. You could do that, but you just need to make sure you got a 110-volt outlet to plug your adapter in. As mentioned, ECUC can be powered directly from your three-phase lines. But other than that, as far as the communication goes, it's still the Zigbee. So both ECUC and ECR uses the same communication platform. Let's just talk about microinverters. Why would you want to go with a microinverter? One of the important reasons is that the safety, right? So with the string inverters in Canada, you go up to 1500 volt. That's pretty high voltage when you think about it. In the US, it's up to 1000 volt on rooftops, but in Canada, 1500 volt. So the typical string inverter, you can have up to 1500 volt DC. High voltage is basically, more prone to arcing, and DC arcing is usually worse than the AC arcing because you don't have that zero crossing, like it's always the high voltage. Um, with the module level power electronics like microinverters, your highest voltage is the panel voltage. Um, for instance, you think about the commercial application, 4 modules per micros. Even though you have 4 modules, the voltages don't add up. It's still one module connects to micro, the others are also connect, but they're kind of in parallel inside, depending on how many MPPTs you have. So they are not in series, they don't get add up. The voltages don't add up. So you get the highest voltage as the module voltage. So right there, you're also compliant with the rapid shutdown requirement because you're not going over the module voltage, and which is considered to be a safe voltage. So low voltage, the max voltage is the module voltage, and you're already by default rapid shutdown compliant. What about the failure impact? Um, you already know probably if you're using string inverters, they have multiple inputs, like multiple MPPTs. Let's say you can have like 5 inputs, 5 MPPTs or 10 MPPTs. But if one goes down for any reason, if there's like a failure inside the inverter, even though you have multiple inputs, it's best not to run that inverter because the failure can propagate inside, and a small failure could lead to something more catastrophic. So you don't want to run anything that is actually failed. You want to shut it up. So what it means is if even if you're losing one string on a string inverter, you're actually losing pretty much the whole inverter and any array that is connected to that inverter. With the micros, you're losing that inverter only, and with the commercial applications, you get 4 modules right per inverter. So you're losing up to 4 modules at a time. You're not losing the whole array. So that is the impact on a failure, right? And from there, it's up to you. Like you can think about, okay, how much does it affect my system? On a commercial system, you lose 1 micro, maybe it's not big of a deal. On residential, you might think about like, oh, I should take an action sooner because you have maybe 10 inverters. Losing one is like 10%. So you may want to take action sooner than later. But on a commercial application, you may just wait there until you get, better time to go and take care of it. And the module level monitoring, that's something you don't get with anything else but a module level power electronics, right? You don't get it with a string inverter. The biggest benefit, obviously, is that not that because you're going to sit there and watch it every day. It's because over time, when you notice that there's a maybe drop in the production, some performance issues, now you can go and check the system on a module level instead of looking at the whole array or string level, even if it's on a string, it could be like 2 strings of the same MPPT or more. You don't know which one is which one is causing the production issues. But just by looking at the module level data, you can even like estimate what kind of failure. It could be maybe the inverter input, or it just could be some issues with shading or a cracked module. By looking at the operating profiles, like how much voltage do I get on this module with respect to other modules, how much current I get. If it's consistently giving a lower voltage, it usually means like part of the module is shaded, like 1/3 is shaded, the voltage dropped by 1/3. If it gives you like consistent lower current, maybe you got bad like a dirt and dust build up on the module. It's not giving you enough current. So these kind of things can be kind of identified by just looking at the module level data. And again, the more importantly, you pretty much know exactly where to look for. So that's like one of the great advantages, which pays you in the long term, obviously. Okay, let's just talk about, as we mentioned, today's topic is the Q22 and QS2 inverters. So we're just going to talk about our Q22 inverters really quick. Um, as mentioned, it's a true three-phase output. It's not like you have three separate modules try to balance each other. This is by design a three-phase inverter. It is compatible with 480 volt AC or 208 volt AC. And so you select the module, the actually the even though they are the same, but you get a different part number, right? So 277 480, that's your three phase, or 120 208, that's another three phase option. They're compatible with the Y and Delta services. And this is like one of the questions people ask, like, does it work with the Delta? Because Delta doesn't have neutral. Some inverters may not work without a neutral, but in our case, we can work without a neutral. So it is compatible with Y and Delta services. It has four input channels, as mentioned. It's a quad module, quad inverter. So got four input channels, but two MPPT. So you got two inputs in parallel, two inputs in parallel. Each goes their own MPPTs. We have a pretty, very wide operating voltage, which covers most of the modules today in the market. As far as the power goes per module, there's not really any limit, but you do want to stay within the voltage and current limits of the inverter, right? So you want to make sure your MPPT range on your module spec is between 30 to 45 volt, and maximum short circuit current is 25 amp. That's the maximum input to the inverter. Now, 20 amp continuous, if it goes above that, inverter will clip, so that should be not really an issue. But 20 amp is your operating limit in terms of continuous operation. But you want to pay attention to the max short circuit current, obviously. So Q2T inverters attached to a 10 gauge trunk cable. That's something we supply. Trunk cable has connectors already, so you plug them directly to the trunk cable. Again, the option is 10 gauge. For the DS3 series, you can get with 12 gauge or 10, but Q22s, we go with 10 gauge only. Um, the differences between 208 versus 480, because the voltage, they are different, you get slight differences in power, right? So maximum continuous output power of the 208 is 17,208 volt amp or watts. For the 480 volt, it's 1800. So just a slightly reduced power on the 208. That's because you have a lower voltage, higher current, but current is limited, so you can't go like all the way high to compensate for that voltage difference. So there's a bit of a reduction in power, not much. Um, Obviously, nominal voltage is 208 for the 208 and 480 on the 480 volt version. You got plus minus 10% range for continuous operation. Currents are different, obviously. 208 is lower voltage, therefore you got a higher current on the output, and 480 is 2.17 amp. Now, because of these current output differences, you have only five inverters per trunk cable if you're using 208 volt AC. 480 is a lower output current, so you can have up to 11 inverters per trunk cable. So if you look at this diagram from our data sheet, you got the micro, four modules, and you have number of inverters on the same trunk cable. Again, for 208, the numbers will be 5. For 480, these numbers will be up to 11. It's your choice whether you want to go with 5 or 4, depending on the layout. Obviously, you want to maximize at 5, but sometimes you get this odd number of modules, and you have maybe the inverter, next inverter is like real further down the roof, and you don't want to just attach one micro to another micro, which is like 50 feet away. So maybe you want to keep that trunk at 5 or 4. But max is your 5 is your max number, and 11 is the max number for the 480. Obviously, we mentioned that's a 10 gauge trunk cable, and that goes with a 30 amp breaker. Let's talk about QS2 really quick. Again, that's our new release, and check with Charge Solar Rep about the availability and the lead time and price and etc. We're excited about this. We had the quad module for single phase applications, but we discontinued it in the past One of the reasons was the certification wasn't up to date. So we kind of waited. Like instead of bringing it up to speed with the certification, we're like, let's just release the newer version, more powerful and more capable version and certify it to the latest standard. So it is compatible, backwards compatible with all of our devices. So I mean, with the DS3, I should say, because it communicates over Zigbee, so it's compatible with our current ECU platform. For the trunk cable, again, you got 10 gauge or 12 gauge, which goes with 20 amp or 30 amp breakers. Under a 30 amp breaker, you can have three micros. If you're using a 20 amp breaker, 12 gauge cable, then you go with two micros per trunk cable. 1920, just shy of 2 kilowatt. So you get 480 watt power per input channel. As mentioned, it is certified to the latest standards, UL 1741 SB. And one of the biggest capabilities is that it has four MPPT. So each module has its own MPPT, which is great news because now you're optimizing on a module level, right? Every module is optimized, not like two module into one MPPT. For MPPTs, you get the most benefit in terms of PV production. Just to illustrate the difference, obviously, the S3, this is what you've been using probably. Two modules, but with the QS2, you got four modules. We put together a quick table just to show you the differences in terms of system size, whatnot. So again, just comparing to the S3L, which is 768 watt, 1920 on the QS2. Number of panels on the DS3 is two. QS2, you get four. How many MPPTs we have? DS3 has two MPPTs. Again, one module per MPPT, but QS2 has four MPPTs. Um, so four inputs, four MPPTs. Output current is obviously much higher because of the higher output power, 3.2 on the DS3L, but 8 amp on the QS2. How many PV modules? If you want to think about like trunk cable and breaker and how many modules you can fit, it is 10 modules per 20 amp breaker on the DS3. With QS2, it is 8. And number of PV panels under a 30 amp breaker. If you go with DS3L, you got 14. With QS2, it is 12. Another important aspect is the DC-AC ratio, right? For most commercial applications, you would have a DC-AC ratio higher than one, but residential, maybe you want to stick to like 1 to 1 more or less because you don't want the power being clipped maybe all the time because of the higher DC-AC ratio. So QS2, you get a more or less 1 to 1 DC-AC ratio. I think that's one of the advantages. So if you're going with the 450 watt modules, you got a DC-AC ratio of 1.17 if you go with the DS3L. But QS2 is 0.94. It's like almost uh, underpowering the QS2. With 500, you get like pretty much one-on-one on the QS2. But DS3L, you have 1.3. As you go higher on the module wattage, DS3L is, having higher and higher DC-AC ratio, but QS2 stays more or less within one to, in terms of DC-AC ratio. So when would you pick a QS2 versus DS3L? Obviously, if you are new to microinverters and you want to just get your hands on these applications, maybe you want to start with the S3L just to get more experience, like just to have a bit of feel like how everything is installed, but for if you're up for cost optimization, just try to reduce the balance of system cost and reduce the number of devices you would need. Like instead of having four micros, you can have only two. That reduces the number of devices you have to install, reduces your BOM. So for that kind of purposes, and if you're experienced installer, you maybe were just waiting for QS2 to be released. So well, there you have. So I mean, pick your option. But again, if you QS2 is more or less about just reducing your overall BOM cost. Since we talked about Q22 and QS2, I'm just going to take a bit of moment here just to show you if you're not really familiar with the wiring system layout. Just like spend like 5 to 10 minutes. So with the quad modules, you're gonna have to connect four modules to an inverter, right? So how do you do that? Obviously, the first step is, mount the inverter on the array, on the rail, and now you're gonna have to connect them to the modules. Now, when you do that, modules have a certain length, PV cable, right? Most modules, they have, I don't want to say most, but from my experience, most of the time they have a shorter cable, like 10 inches or so. Some of them have about 50-ish inches, like 1.2 meter. I mean, it's always good to go with a module which has a longer VIPs, longer PV cables, but even that is not really going to reach all the time to your microinverter. So you're going to have DC extension cables, which we supply. Again, check with your Charge Solar sales rep and try to get the DC extension cables pretty made. Like you can do them on the field, but we don't really suggest that. I mean, you could have, not maybe you have a bad crimping or not crimped well or some errors on the crimping, making that cable that causes issues later down the road. So you have different options in terms of layout, like how would you connect the micro to the modules. It really depends on the overall layout, right? And I'm going to show you one very simple example, but you can choose 2x2 landscape or 2x2 portrait. It also depends on your racking, right? Whether you're doing portrait or landscape. Another option is 1x4. If it's a portrait, you go like this, 1x4. And again, this document, I took this snapshots from the document, which is available on our website. You can go and search for like DC extension cables in our library, and you can take a look at these kind of illustrations for different inverters. So again, you can go with any of these depending on your layout, but then what's going to be the next? The next step is your trunk cable, right? Now you put the inverter connected to DC wiring, now trunk cable. Trunk cable is the AC output basically that is connecting your micros to your breaker panel from there to the grid. Now, with the Q22, for instance, this is for the Q22. As mentioned, you get number of inverters per trunk cable. If it's the 208 volt version, you have five. If it's 480, you have 11. So these trunk cable, in terms of 480, let's say, in the case of 480, it will have 11 inverters. Now, the distance between each microinverter is something that you would try to optimize because you don't want them like very far apart. Let's say they are within 3 meters of each other, then our options for the trunk cables like 2.4 meter, 4.6, and 9.5. I mean, 9.5, we don't really use it really. Most commons are 2.4 and 4.6. I should say 4.6 meter is more common than 2.4 because it gives you more flexibility in terms of wiring. Like you don't have to worry about squeezing them closer to together. But so basically 2.4 means you've got 2.4 meter distance between each connector. If you go with a 4.6 meter trunk cable, then you have 4.6 meter distance between each connector. So that's important. So you want to choose the right one. If the micro inverters are away from each other, but about 3 meter, then you need to go with a 4.6 meter because 2.4 is not going to reach. Then what do you do? Like if you're not reaching to the microinverter, one of the options is that you skip one of this connector, go to the next connector, and you need to seal this one. And we have the cap for that. But then you're wasting a connector, right? So when you do the layout, look at the inverter spacing and choose the trunk cable accordingly. Um, One end of the trunk cable is going to be capped, obviously, because this doesn't go anywhere. The one that goes to the grid, what you basically do is you cut it and then bring it to a junction box, and from there make your extension cable. You can use the 10 gauge cable, even different gauge cable, like maybe 10 or 8. And then from there, you extend it to your breaker panel. So this end basically goes to your breaker panel and it's going to land on a 30 amp breaker. Just to give you a quick illustration, right? Let's say you have a very nice layout like this. It's 4 by 10. I mean, I know you're not gonna, come up with this all the time where you're gonna have something very different, but just to give you an idea. Again, in the case of 208 volt, I have 5 inverters per trunk cable. Now, you got 4 modules horizontally, sorry, vertically, and I got 10, so 4 by 10. Um, so to me, the best option is to go with 2 by 2 portrait in this case. Basically, we are going with this one. Why? It's because when you think about it, you place the inverter on under the module right there somewhere, and the distance between the micro to the module is not that long, so you can probably get away with 1 meter extension cables, especially if the panel already has like 1 meter cable. So from the DC connectivity, it's pretty much optimized, and you get a like, very nice straight trunk cable. That's really optimal, I think, because you don't have to go from here down up doing like zigzag. It's pretty much straight line. So this would be like my choice if I'm riding this. Um, Again, if this was a 480 volt, then I can have up to 11 inverters, which means I need to make a loop somewhere. So in that case, you could go just like this again and continue the wire, the trunk cable, make a loop like that go down, and one end will be kept, the other end will go to the breaker panel. Or you could do another option if this was a 480 volt. Again, you can have up to 10. You can do maybe 1 by 4 and one inverter here, one inverter there, another inverter there, 10 in a row. You can run a just straight trunk cable. The only caveat there, even though it looks very practical, just a little caveat, then which will be like the DC extension cables will be a little longer. Like if you put the microinverter, let's say somewhere down here, maybe you have like a walkway here, so you want to have easy access. You put it down here, then you have to reach to this top inverter. It's going to be like each panel is usually like 2 meters, at least 2.2 meter. You got like more than 6 meter length to reach. So that's something that you may want to think about when you're designing your system. But again, you can choose any of the options when it comes to layout. Can do 2 by 2s, 1 by 4. I normally like to optimize for the trunk cable. With the modules, you can connect them with the DC extension cable. It's not really a big deal, but trunk cable would be, it's a 10 gauge cable, got the connectors. You want to also reach every inverter, so you may want to optimize around the maybe trunk cable. So in this case, again, just to summarize, 5 inverters per trunk cable because we are using Q22208. It's a 10 gauge trunk cable. And data sheet summarizes the details about the, how many inverters you can have. 5 on the 208, 11 on the 480. So this one again, optimal for the trunk cable and pretty good choice for the DC runs. Now the trunk cable, again, we have options, which are 2.4 or 4.6. Now, when you look at the distance between the micros, each module is usually 1.1 meter wide. So you go from here, 1.1, 2.2. So in this layout, I think you can comfortably go with the 2.4 because especially if you don't have much space between the modules, they're like flushed against each other. The distance seems to be like 2.2 or 2.3. And plus you have like more or less 2 feet of VIP on the inverter for the AC connection. So in this case, I think going with the 2.4 meter would be a good choice. But again, if you do a different kind of layout and inverters are far apart, and in that case, your next choice is 4.6 meter. just to give you some installation tips based on the things that we discussed. So inverter spacing is important, trunk cable important. So you may want to optimize around that. Like don't run the trunk cable from here to there. Try to run like a straight line. Keep the inverters kind of close to each other. So you can use a 2.4 meter cable, 2.4 meter trunk cable, or 4.6. We also suggest again use pre-made DC extension cables. Like you can again make them in the field, but because of the errors and things like that, you probably better to go with a pre-made cable. And you make sure to allow enough space, sorry, enough wire length. Make sure you have enough slack on the wire so you don't pull too tight and don't put any tension on the connectors because if you're putting a tension on the connector because the wire is pulling on the connector, over time it's going to be like have it's going to lose its watertight capabilities, it's going to arc. So you definitely want to avoid that. And sticker map is very important when you lay down your inverters. Make sure you peel off the sticker from the inverter and put it on the sticker map. This could be a paper or a cardboard box, but make sure you know where each inverter is located in your layout. Um, okay, we're going to talk about the AC combiner box, but before we get to that, I just want to mention about the ECUC really quick. As mentioned, the ECUC has this capability to measure power of the production and the consumption site. So through the CTs. So we wanted to have this similar capability for our commercial, so for our residential applications. So we came up with the AC combiner box. So finally, with the AC combiner box, you can have your production and consumption and import-export data. And how do we do it? With the AC combiner box, you get a chint meter built into the combiner box. So with the chint meter, you're measuring the PV production using the CTs and you're measuring grid power using the CTs. That connects directly to the ECU and you get the data through the ECU from the chint meter. It has one of the breakers already populated for internal powering. You power the meter, power the ECU, but the rest empty slots there, you need to just populate them with just off-the-shelf breakers, nothing really special. So with the AC combiner box, we got the consumption and production metering. CTs are installed for the production, but grid set CTs, because you need to install them on your main service panel, they are not inside here. You just need to install them and bring it into the combiner box. Got a revenue grid metering with the chip meter. And I also like to mention that we recently modified the AC combiner box. In the past, we had the ECU, which was cellular plus Ethernet, but we got a request from our installers and saying that we need Wi-Fi. So we basically swapped the ECU with a Wi-Fi compatible ECU. Now you're going to get with this new part number, again, check with your Charge Solar sales rep, ask about the new AC combiners box with the Wi-Fi capability. Um, so you by default now you're going to get with this new part number, you're going to get the Ethernet and Wi-Fi capable. If you still want a 4G connectivity, you just get a dongle. That's sold separately. So basically, you got the default Wi-Fi plus Ethernet, 4G optional, and then obviously you're going to get the SIM card data on the SIM card, plug it in, and now you can have all these options, Ethernet, Wi-Fi, and 4G. You get up to 88 amp solar, which translates to 110 amp of total breaker size. IP65 and UL 1741 compliant. Here is just an overall diagram. All the micros go through the CTs and in the AC combiner box, that's how you get the PV production measurement. And grid CTs are installed externally. And these are CTs are provided, PV CTs are already installed. Just wanted to show you the internals again. So we've got the chip meter communicates with the ECU. This ECU with the new part number now has Wi-Fi, Ethernet, and if you want a cellular, you just plug it in a dongle with the SIM card. You're good to go. These are the PV production CTs. So you bring your line one through the first CT and line two cables through the second, land them on the breakers, and at the bottom These are the logs, the main logs. You take the total production through the cables, bring it to your main service panel. Just pay attention to the labels on the breakers. So it goes like line one, line two. There's an empty slot here, so it becomes line two, line one. So when you land them, just pay attention to these labels. Again, just another diagram showing how the microinverters are coming through the knockouts here and going through the CT. And for the output, you bring them from the lugs, attach it to your main service panel. Now I'm just going to show you the CTs, right? When you bring the output from the line one and line two lugs, attach them to your main service panel. Where do you install the CTs? Well, CTs are going to be installed on the main service entrance, okay? Don't install them on the breakers that you are tying your output to. They need to be on the main lines entering your main service panel, like at the main entrance between the breaker and the grid. You're going to install them there. Once you install them there, just bring the wires to the meter. The PV production CTs, they're already pre-wired, but because these are installed external, they are not pre-wired. So you just need to bring them to the meter. They have the labels, like where do you land them? It's already labeled. So these are the grid CTs. You're going to be connecting these wires right there. And then you will get this data. It shows you the PV production, how much you're importing or exporting, and what is the building consumption in this graph. And it is revenue grade because of the AC combiner box has this chip meter. It's a revenue grade meter. Lastly, I just want to talk about two features on the EMA. One of them is the auto refresh. So when you do local access to your ECU, you can click on this button on the right top. It gives you data in seconds. Normally, you wait for the data for 5 minutes, but in this case, you don't have to wait that long. All you have to do is, again, click this button, enable this feature, and then you can get the data pretty much instantly. And it is very good in terms of troubleshooting, right? Let's say you're dealing with some kind of errors or fixing something and you don't want to wait like 5 minutes for the data to come. Using this feature, you get the data every 5 to 10 seconds. About the upgrade, now this is also a new release that basically allows you to download the firmware, also software, to your device, and then you can locally upload it to the ECU. So once you log into your EMA manager, it will prompt you to download the firmware. Let's say, you got a new firmware, you want to download it, you download it to your phone, and when you connect to the ECU locally using local access, it will say there's like a new firmware. Do you want to upload it? So when you do local access, now you don't have to worry about having Ethernet or connectivity because you're doing local access. You can push that firmware from your phone directly into the ECU. That's another feature of the EMA. Not sure if you ever used our AP Designer, but as we talked about the system layout today, you can utilize our AP Designer tool, which basically allows you to create the, layout, like all the wiring. You can do it like auto wired or you can manually wire them. All you have to do is uh, basically sketch your modules just like I did and upload it. Once you upload it, you just need to tell the dimensions by showing a basic distance from point A to B. It so then calculates the distance and the dimensions of the layout. And then you can basically say, okay, draw it for me or like give me the layout. It drops all the microinverters and wires them for the DC, wires them for the AC. Then you can start playing with it like, okay, I like this one, but I don't like that part. So then you can start manually adjusting it. Once you're comfortable with your design, you can export the BOM. basically click on that download button, and then you will get the bill of materials for that layout that you just submitted to your AP designer. And yeah, it is again on the website. It's on the EMA account, free of charge, just like our other tools. So go ahead and try to utilize it. That's definitely a great tool. So for the training resources, we have AP Systems Academy, and we strongly recommend our installers to go through the ECU training at the bare minimum, because whether you're dealing with the storage or not, but you're always dealing with the ECU. That's your, that's the equipment that you have to work with to commission the site, to access all the inverters, and again, do all kind of settings, the mapping, etc. So you really need to understand how the ECU and the EMA works. Again, ECU is the energy communication unit. That's the hardware. EMA is the energy management application. So that is the basically the portal that you monitor, do the settings, commission the site, do mapping. So I should say again, the ECU and EMA training is really really necessary for you to learn how to commission the site and how to monitor the site. And if you're doing storage applications, then we have a training for the AP storage. That's for the ELS 11.4K. That's another great tool if you're doing any kind of storage installs. But again, ECU and EMA is like one of the most important ones that we strongly recommend you take the training and learn about it. And yeah, you can go ahead and create your EMA registration portal. You just need to upload some information, and then you'll get the account approval. With that, we can conclude today's webinar, and we can see what kind of questions we got.
Yeah, so first one was from Jason Wilson, who just wants to know if you can hook the ECU-C to a 347 600 volt three-phase service, Canada.
Well, 277 line to neutral and 480 line to line is the max. There's a 10% threshold for the max. That's because your line voltage could be like 10% higher, but that's pretty much the limit. 480 plus minus 10% line to line is the limit.
And that's the only, oh, who does support, centrally in USA or separately in Canada?
Well, we have a support team located in the US, but we have dedicated team for the Canada and dedicated team for the US. So there's a separate team for the Canada support.
All right. If that concludes questions, then thank you for your time today, Zach, and for your detailed presentation. Thanks to everybody who joined us as well. This webinar recording will be emailed to all of you by the end of the day and will also be added to our YouTube channel, which I'll share in the chat for your reference. There we are. All right. Thanks so much, folks. Zach, it's always a pleasure. Thanks,
Thank you.
Travis.
Thank you again. Thank you, everyone, and thank you for the opportunity.
Take care, everybody. Have a good day.